composition of functions. This is where you wrap one function inside of another. So kind of the way you see it written, you'll see they'll use this, they'll call it fog. And that's not really an O, it's like a degree sign, but not at the top, it's in the middle with Malcolm. And they'll say fog or f of g of x. F of g of x. And all that really is the function g, here, whatever it's going to be, wrapped in or put into the function f, the outer function. And what this means is everywhere, if you have the original function f, everywhere you see the variable, you put the g of x function into the variable there. And so that's where the word composition comes up. You think of it being composed. This is f composed of g. And yeah, that's exactly a fine way to think about it. Nothing wrong with that. So let's actually look at an example of such a process. Let's say that you have f of x. Oh, here, I'll write it down here. F of x equals 3x plus 4. And g of x is a quadratic. How about 7 minus 2x squared? Well, we're not, Presley sends a question. We're not going to do the entire review. I can work some problems from the review. Actually, to do the entire review, we'd have to go lightning round where I wouldn't have time to explain it. We're going to do a chapter 2 review today. So any questions you have for me over chapter 2 is what we're going to work. You can bring in the questions from the chapter 2 review from MyLabs Plus. Today is really just your day to ask me anything you have about exam 2. That's what you gotta have. That's what you gotta do. So let's see. We've got these two functions, f and g. Let's first find, just for kicks, let's find f of g of x, and let's also find g of f of x. Let's put one inside the other and the other way around. So let's do f of g of x first, which remember is going to involve us putting g inside of f. So everywhere we see the variable here, we take our g function and put it in there. So this is going to be, well, 3 times, now let's put the g function in there, 7 minus 2x squared, and then there was a plus 4 outside of that. So for lack of a better term, this is kind of the easy one. We'll distribute this 3 and combine any like terms we've got. 3 times 7, 21. 3 times negative 2x squared will be minus 6x squared. And then there's this plus 4 out there that did not get touched by the 3 or an angel. So we have 21 minus 6x squared plus 4. What we should do now, we should write it in descending order and also combine like terms. So the only like terms are going to be the 21 plus 4, which is 25. But I'm going to write the minus 6x squared first, and then I'm going to say plus 25. And that's in descending order, where you put the highest powered term first, and then you go down the line. And so that is f of g of x, f composed of g. Well, that one is not so bad. The other way around is going to be the one that requires a little bit of next level thinking, maybe. So if we go the other way, if we do Goff, g of f of x, we're putting the function f here, we're putting that whole thing in everywhere we see the variable on the g function. All right, so here's our g function. This is kind of like the outer function. I'm going to take this 3x plus 4 and put it into the variable on g. So it's 7 minus 2 times, now I put in my 3x plus 4, and it's squared. Now remember, when you have something like this that's squared, squaring something is ultimately going to be to say you multiply it to itself. So now I'm going to do 3x plus 4 times itself. And so I'd use FOIL here. I would use FOIL. We'll still end up having to distribute the 2. 3x times 3x is 9x squared. 3x times 4 is plus 12x. 4 times 3x plus 12x. 4 times 4 is 16. Now you have plus 12x here in the middle. All right there, Pilgrim. Let's just combine like terms. It's going to be plus 24x. And voila. Now I've got 7 minus twice that, so I need to distribute this 2, and it's a negative 2, really. So now you can already see this one's a lot more complicated than the other one was. It'll become 18x squared minus 48x minus 32. And now the last thing to do is to combine like terms and then write it in decreasing order or descending order. So then minus 18x squared doesn't have any like terms. It'll go first because it's the highest powered term. Minus 48x is the next highest powered term, doesn't have any like terms. Now finally we have minus 32 in positive 7. We're adding 7 to that. So that's still going to be negative. And then 32 minus 7 is 25. So that's going to be minus 25 at the end of things. And so they are just nowhere near the same thing. This was negative 6x squared plus 25. This was a lot more complex, and they don't come out the same. So putting one inside the other is not the same as flip-flopping. So good questions there. So now I can work something from the review, because remember we wanted to work the review over the weekend and bring in any questions you have over it. So does anyone out there have a question from the Exam 2 review that's on MyLabs Plus?
Number 3.
Number 3 sounds good. Let me pull that up. Number 3. So this one is going to involve completing the square. We're deciding whether or not this thing is going to involve a circle with a graph. And so let's see. Let me pull it up. Let me write out the equation. No, don't open that. 81x squared plus 81y squared. Minus 72x plus 72y. Minus 32 equals 0.
So you all have different number three?
Yeah, what it does is it generates slightly different numbers for all of you. So I can either work this one that I got, or whoever asked to do number 3, you can tell me what your numbers are.
Anybody disagree with 13? You would do this one, or you would- Yeah, I guess this one's fine. Look, he's gonna do this one, if he needs your help on this. I can help. Go ahead.
Okay. So just to preface before we even really dive into this one is just going to involve fractions. This one's just going to involve fractions, and there's just no way to dance around that. So this one is going to be a little bit tedious, but I believe in all of us. Okay, so the first thing we're going to start is we're going to remember that we'd like to write an equation of a circle in this form. We'd like it to be in this form. There's a few subtleties to that. For one, notice there's not like you can't put a 3 there and a 7 there in front of that. What we want is a 1 here. If there's nothing written, there's an implied 1. So a big component of what we're going to have to do is make sure there's a 1 ultimately in front of the x squared and a 1 in front of the y squared. Which, since they both have an 81 in front of them, we can divide both sides by 81, or divide the whole thing by 81, and that's going to take care of that for us. But now you see that it'll immediately involve us writing out fractions. So it'll get a little bit nasty. I'm just going to have to assume you guys are fairly solid in the realm of fractions. But what we're going to end up doing is completing the square twice. So let's work it together. The first thing I would like to do is I'd like to have this constant on the other side, because remember in the equation of a circle, which I just erased it, so I'll bring it back. My radius is a constant that's going to be on the other side, my radius squared. So maybe I'll do that. So add 32 to both sides, and now you're going to end up with this equals positive 32. Very good. Now notice another thing. We want a 1 in front of the x squared and a 1 in front of the y squared. Since they both have 81 in front of them to start with, if I divide both sides by 81, that will do what I want. If this had anything other than 81, if it had 8, that's not going to fly, and suddenly you're actually not going to have a circle. Because if I divided everything by 81 to get this one situated, I'd still have to get this one situated, which is going to screw up what I just did for the x squared. So the only reason this ends up working as a circle is because the x squared term and the y squared term have the exact same coefficient of 81. Anything else, and that's going to be a problem. So I got to divide everything by 81. And there's just no way to dance away from that. So now what I'm going to do is I'm going to split this up into a bunch of fractions. This will be, or you can just say I'm dividing each individual piece by 81. So let's see if I can kind of jump to the fun here. That's going to leave me with x squared by itself plus y squared minus 72 over 81 x plus 72 over 81 y equals 32 over 81. Something that is going to be especially frustrating is that this 32 over 81 does not simplify into a fraction with lowest terms, or rather it already is a fraction in lowest terms, because 32 is just a bunch of 2's, it's prime factorization. 81 is a bunch of 3's, so they're not ever going to have any cancellation. But I can simplify 72 over 81 in both cases. 72 and 81 can both be divided by 9. So this ends up becoming minus 8 over 9 x plus 8 over 9 y. And there's still your x squared plus y squared going on. Now the next thing we want to do is we want to complete the square. We want to complete the square so that we can get the x's kind of all together, because we always want to remember what the basic form of a circle looks like. It's going to look like that. So we're trying to make that happen. It's going to suggest we complete the square. Let me write that a little bit better up here. So I'm going to rearrange a few things. Whoa. Oh. I'm going to put my x's together, all of whom live in Texas. I'm going to put my y's together because that is y's. All right, so now we got to go to another page because I'm running out of space. So we're going to say this is the step we're at now. So we want to complete the square. We want to complete the square for the x's. Remember, completing the square is that process where we take half of the number that's in front of just your x term, in this case, x to the first. We want to take half of that number. So half of 8/9, we can just divide the top by 2. Or you can tell yourself it's multiplying by a half. And then what we want to do with that is we want to square it. We multiply it to itself. It's going to come out positive 16 over 81. Oh, that looks bad.
Okay, where did we lose you? Where's 4/9 at? It's the middle term divided by 2.
Right, it's the coefficient of this middle term here.
Divided by 2.
We divide it by 2, and then we square that. And the reason that works out is that's going to create a perfect square trinomial for the x's here. And what we're going to do is we're going to take this new 16 over 81 that we just discovered, and we're going to add it to both sides. I'm going to add it here. I'm going to add it here.
Sorry, half the top. Half the top. Yeah. Well, if it's 2/5, you would, yeah, do 1/5. Just half the top. If you can't have the top, you can also, I think, go to the bottom. You can kick that out. I would just do it. Okay, where do you lose here? You just squared the negative 4/9. Huh? They're just completing the square, yeah. It just happens to have fractions. Is their test going to have completing the square with fractions?
There's a possibility, because unfortunately it does randomly generate numbers. Although I have kind of looked through the test, But I mean, yeah, it's always possible.
Right, yeah, no, I know. You know, and I didn't take that into consideration. Okay. Anything you add to one side, the other you do. If you choose to add that 1681, 16/81, you have to add it to the other side. And then square it, and then you add it to both sides.
Yeah, that's our completing the square process. We take half of that. So you could say you're multiplying by a half. That's going to become this if you multiply your fractions. But then if you put that in simplest form, that just becomes -4/9. The trick I did was to say, oh, I'm taking half this fraction, so I can just take half of the top number, and it would have become -4/9 anyways. And go ahead.
You put the blanks in. And correct that, yeah, we all. Okay. So you need to draw the blanks in and remember what to do. So take this divided by 2 squared.
And then we square it, we multiply it to itself. It's going to become +16/81.
It's also the one for the left. Add the numerators. Add the numerators. Common denominator, add the numerators. 32, 16.
So we started using the -8/9. So I thought that went away whenever we got when we did that. and we
No,
got the
'cause we're gonna-
16/81.
We're gonna factor, I feel like I'm interrupting.
Oh, I see.
We're gonna factor this, and we're gonna factor this. Okay.
And then aren't you able to square root into this one?
Yeah, you have to square root. Well, you're not gonna square root that side, but you're actually drawing the circle. He's gonna hopefully. Oh. Sorry, you're good. I think you can go on.
Okay. Yeah, what I would do is I would review the completing the square procedure. We're completing the square for the x's first. We're basically kind of pretending like the y stuff isn't there. Then we'll come over and we'll complete the square for the y stuff. But this is just the procedure for doing it. We take this value with x, we take half of it, then we square that number, then we add that number to both sides of the equation. What that's going to do is that's going to create a perfect little scenario where this new thing that I'm about to write is going to end up factoring perfectly. So let me show you. It's going to factor as what we call a perfect square trinomial and look something like this. So here in a moment, we're going to rewrite it like this. And even though the numbers are fractions, the math works out exactly the same, where this will ultimately factor like this. That's why we went through the process. If we took half this number, squared it, and added it to both sides, it now creates a situation where it will factor perfectly like this. It's almost like doing the reverse of squaring a number or squaring a binomial like this out. And so that's our completing the square process. So we'll preview that in just a moment. We also need to complete the square for the y's. So again, we've got y squared plus 8 over 9y. We need to take half of the 8/9. We need to do 8/9 and take half of it, or multiply it by 1/2. We're going to get 8 over 18, which simplifies into 4 over 9. It's very similar to the last number that we just did all that with, except it's positive 4/9 now. Then we square that number per the completing the square process, and we're left with 16 over 81. So once again, I'm going to add another 16 over 81 to both sides, but I'm going to put that one in here next to the y's.
So you completed the extra
Oh,
one.
that got it there.
The stuff in red is what you added. Okay.
So now for the y's, I have y squared plus 8 over 9y plus 16 over 81. And now on the right-hand side, I have 32 over 81 plus 16 over 81 plus 16 over 81. We have the immediate good fortune that these all have the same denominator. So if I combine them into a single fraction, 32 plus 16 is going to be 48, plus 16 again is going to be 64. And now the whole process, the completing the square process, then dictates, we take this thing, this here, and we say, we've got 8/9. Well, we're going to end up writing that as x minus half that squared. And if you don't believe me, you can try foiling this guy out. You can do x minus 4/9 times x minus 4/9. After you combine like terms, you'll get exactly this. So this was the whole reason we went through that song and dance, is because it creates a perfect squared trinomial. The y's here also create what we call a perfect squared trinomial, only it's y plus 4/9 in this case. And all that is equal to 64 over 81. And now here's what we can definitively say. I'm going to bring this is how we've changed the equation. And I'm sorry, there's supposed to be a squared on that. X up here. That got deleted, I guess. Now we have this written in this form. We have x plus or minus something here squared, plus y and then something squared equals some radius. This is already being squared. So the only other thing we can do, we can say that in this form, r squared is this 64 over 81 business. It's the business on the right-hand side of the equation. And so the radius of our circle can be found by taking the square root of both sides. And we have the fortune of, well, 64 is a perfect square, 81 is a perfect square. And so the radius is just 8/9. The radius is just 8 over 9. So we have a circle with a radius of 8 over 9. Now you might say, don't we have to do the plus or minus thing? And normally I'd say yes, except this is clearly meant to be the radius of a circle, and a radius shouldn't be negative. That doesn't make sense. So we can ignore the negative part of that at this point. And now it's written in this perfect form, this wonderful form here. We're going to have a center Well, using this form, the center is positive 4/9 because there's minuses in the equation. So we take the opposite. So it's positive 4/9 is the x coordinate. The y coordinate is negative 4/9. It's the opposite sign. So we have a circle with this center, 4/9, comma negative 4/9, and a radius of 8/9. So some of the questions it's asking, do we have the equation of a circle? Yes, we do. And its center is 4/9, comma negative 4/9, and its radius is 8/9. And so that's about the long and short of it. So technically, it is possible that you could have this where you have to complete the square and it involves fractions. So this might be a good one to review, but this one's in the books. Now let's talk real quick. Let's talk about some resources you can have for additional study here. Obviously, you have the exam to review on MyLabs Plus. What I'm going to do today is I'm going to hold a review session at the Weatherford College campus in the academic building, room 129. So at the main campus in the academic building, room 129, we're going to go from 3 o'clock till, well, normally we go from 3 till 4, but I'm willing to do 3 till 5 today. Are there some of you out there who can, I know you don't get out of class till maybe 3:30. Are there some of you out there who can do 4 till 5 p.m. who can come to that part of the session? Maybe raise some hands. Is there anyone who can do 4 to 5 today?
They're asking if you can Zoom it or something.
If I can what?
Do it on Zoom.
Actually, yeah, I could do it on Zoom. What I can do is I can either give you the option of coming in or attending it on Zoom. And what I can do is if you do come in, I'll just be on Zoom, but I'll be there live in person, and I'll project the Zoom image onto the whiteboard because we have projectors in our rooms. So are there some of you who would want to come in person? Is there any, can you do a show of hands?
Nobody's on person.
Nobody
Yeah.
can make it in person today?
Great.
What's that?
No, they can come.
I'm sorry, I can't hear you.
They can't make it.
They can't make it in person? Okay. How many of you would come if we did a Zoom session? How many of you would come to the Zoom session, I mean?
Like today?
Yeah.
Nine people raised their hand.
Okay, so we'll do a Zoom session. I'll plan to do it from 3 till 5 p.m. today. I know some of you don't get out of class till 3:30. What I'll also be doing is I'll be posting this review we're doing right now into YouTube. So you'll be able to watch this later as well. But yeah, we'll also try to do for 3 to 5 today. We'll do a review session.
I can do probably tomorrow on Google Meet. Wednesday, I can maybe do that.
Now I can't always promise I can do a review session for the week of the exam. It just depends on my schedule, but it turns out today I should be able to do today from 3 to 5 on Zoom. So does everyone know how to get into Zoom from your individual computers and all that? If not, remember the Zoom link is just found in our Canvas page for the course. And so you can post that in a web browser and then it'll open up your Zoom app or whatever you're using, your program. And so yeah, that's how you can access Zoom. And then you can ask me specific questions or something like that. How does that sound? Hopefully uber good. Okay, so we'll meet in Zoom today starting at 3. Let's keep going. Who else has a question they'd like me to work, either from the review or something else like that? Let's see, we got 15. Question 15. Okay, a little bit of a fun problem here. Now, I'll just say right now, we can do this one, and we will. This one, if you ever need a calculator, then the problem is not going to be on an exam. This one shouldn't actually need a calculator, but we'll work it. So maybe I'll just show you what's going on with this one. I'll just put my screen on it. Okay, so this is an application problem. The light market vehicle share of a particular country for pickup trucks is shown in the graph. So here, x equals 0 is going to represent 1995. So we're going to say in 1995, 42.2% of the pickup truck market share was light vehicles. That just means that of all pickup trucks out there, 42.2% of them were light vehicles. They were smaller, I guess, pickup trucks. In 1999, since that's 4 years after 95, we're going to say that's really the x coordinate of 4. And then in 1999, there was 39.6% market share for light vehicles. And then 4 years after that, in 2003, so the x coordinate is 8, there was a 32.7% market share. So what it wants us to do is it wants us to say, well, it shows the completed problem, but we'll work it together. I'll show you why this makes sense. The equation for the line segment in the interval 0, 4. So it wants to know the equation of this line segment. So it's a line. It's a line. So what we need to do is we need to create the equation of a line here between these 2 points. So that's really what it's asking first and foremost. So let's work that together. We want to find the equation of the line passing through the points 0, 42.2, zero comma 42.2, and then our other point is going to be 4 comma 39.6. So that's how we'll start this one off. Well, let's remember a few key formulas. The slope of a line crossing through 2 points is y2 minus y1 over x2 minus x1, where we will say this is x1, y1. So we're going to need to find the slope of the line first. So we're going to have 39.6 minus 42.2 on top, on bottom 4 minus 0. It's just the changes in the y's divided by the changes in the x's. So now on top, we see we're going to get a negative number because we're subtracting a larger number from a smaller one. And now we just do this. And so we might be able to just skip to the punch, and we see that that's going to be, what, 2.6? So it's going to be negative 2.6 on top. And on bottom, you're just going to get 4. Now, we don't necessarily want to leave it as a fraction. It looks like what we want to do is actually convert this into decimal form. So we do a little long division. We know that's going to come out to a negative number. So now we don't bother with the negatives when we write it in here. 4 doesn't go into 2, so we need to go up to the next. 4 will go into 26 6 times. With this remainder, now once you're after the decimal point, you can give yourself as many zeros as you want until you can complete the problem or see a pattern form. So now 4 can go into 25 times, and it'll do so cleanly, leaving you no remainder. So it's negative 0.65. And sometimes you can put that 0 there before the decimal just to highlight what's going on. So now what we're going to do is we're going to have this slope to our equation. Now we can use the formula to actually create the equation here, to create the equation of the line. We can use this as x1, this is y1. And so now we'll have that. Now x minus 0 is just x, so we don't need that, and really we can drop the parentheses as a result. Then I can just add my 42.2 over onto the other side. You'll end up with the equation y equals negative 0.65x plus 42.2. And so that's going to be, there we go. That's going to be this first linear equation here. So it's the equation of just this part of the segment. It's this line segment. Now it's going to want the equation for the line segment here. It's going to want you to find the equation for these 2 points. So you have 4 comma 39.6. That's your x1, y1. Your x2, y2 is 8 comma 32.7. So you would end up going through the same process as we just did before. Find the slope of the line first, and then find the equation of the line based on that. And so they would end up getting this. And all you have to do to make it a piecewise function is to say that in this first interval here, this is the equation of the line, negative 0.65x plus 42.2. In the next interval here between 4 and 8, this is the equation of the line, negative 1.725x plus 46.5. And so that's kind of what we end up with. Other questions? What else do y'all have? I can also work a question. I can work a problem that I think will be helpful. Do y'all want me to do that? One that I'll make up off the top of my head that I know is going to be something likely on the test. How does that sound? So let's do one where we compute the difference quotient of this equation.
You're really supposed to learn to do it ahead of time. And then if you put that question on, you'll be working.
So let's compute the difference quotient for this function, negative 3x squared plus 2x minus 8. Remember, the difference quotient is this business here. So the standard procedure is to first find f of x plus h, where h is a new variable we're basically kind of introducing into the mix. Then we subtract off the original function, then we divide all of that by h and see if there's any way to simplify it. So we'll do this one step at a time. We're going to plug x plus h into, and so this is a great question over function composition. We're going to put this in for the variable everywhere we see it. And now what we want to do is we want to simplify that as much as we can. So first I'm going to need to do x plus h squared. Which involves me multiplying it to itself. And then we'll deal with this business here in just a moment. So x plus h squared, we FOIL that out. X times x is x squared plus x times h is xh plus h times x, but that's the same as just xh. We kind of discussed last time why we want to write it in this way, plus h squared. And then we argued that these two things in the middle here are like terms. They're like terms. You have a single instance of xh plus another instance of xh. So you're going to end up with two of them. You're going to say that's 2xh here in the middle. And then we'll shrink this a little bit. And now finally, we can distribute this negative 3. Minus 6xh minus 3h squared. And then we kind of passed over this part, but now we'll actually deal with it. We need to distribute this 2. So it's going to become plus 2x plus 2h. And then there was a minus 8 out here the whole time. So while it looks complicated, we didn't do anything, I think, that was too out of bounds or anything. We've done the first part of this process, which is to find f of x plus h. And it turns out to be this whole thing. So that's step one. And now because I'm out of space, I'm gonna need to erase. Our next step, we're gonna do the entire numerator, f of x plus h minus f of x. But the beauty of that, we just found f of x plus h to be this whole nasty monster. Now what we got to do is subtract off the original f of x, which was negative 3x squared plus 2x minus 8. We got to subtract the entire thing. So I put it in parentheses. So what that's going to do for us, this whole first business doesn't change. Negative 3x squared minus 6xh minus 3h squared plus 2x plus 2h minus 8. So now we have minus a negative 3x squared becomes plus 3x squared minus 2x plus 8. And so all of this is going to look bad, except now there's going to be some cancellation happening. We have negative 3x squared here plus 3x squared. Those are like terms, and if we combine them, they would just combine to 0. So this is gone. Then we have plus 2x minus 2x. We combine those like terms, that also just goes to 0. We have minus 8 plus 8. And so what we're left with after the dust settles is negative 6xh minus 3h squared and then plus 2h. So we've completed step 2. We've computed the entire numerator here. So now we're going to do the entire thing, which is to just take everything we just did and put it over h. So we just take this, put it over an h. The way this is going to simplify, you can actually factor an h out of the top because everything is being multiplied by an h. So we can factor an h at the top. And the whole reason we're doing it is so that it'll cross out with this h here on bottom. And what we're left with is negative 6x minus, there's still a single h with the 3, plus 2. All that's over h. And we did all that to get rid of those h's. And now what we're left with is negative 6x minus 3h plus 2. So this business here is the difference quotient. It's the fully computed difference quotient for this function, negative 3x squared plus 2x minus 8. This is it. If you were taking calculus, you would go one extra step. You would take what we call the limit as h approaches 0, and that would actually make this thing disappear, this middle 3h here. And the leftovers, negative 6x plus 2, would actually be called the derivative of this function here. The derivative. So a difference quotient problem is definitely one that is worth investigate and remembering. Yes, you will have to know this off the top of your head. You'll have to remember this here. So if you work a couple examples of this here, it's just gonna kind of be seared into your memory. One thing I can say, so we have the exam to review here. We also have chapter 2 homeworks that you've already worked. As long as you've attempted to work them before, which I think all of you have, what you can do is in MyLabs Plus, you can click on the grade book. You can go over to the previous homeworks you've worked, and you can actually open them up and review them. And you can also have it generate a new problem for you. So say you're like, oh, number 4 on the 2.4 homework. That one gave me a lot of problems. So I'm go in there, I'm going to have it regenerate a fresh problem with fresh numbers. It will not mess up the work you've already done. You have already gotten credit for that problem. It will not mess it up. It's just giving you a chance to practice it anew. And it won't improve your grade because that homework is already past due. But it is an opportunity for you to practice some. This difference quotient business is found in the function composition section of your homework. And so this is one that I would probably focus on, or at least work a couple times over. And this formula will end up just kind of sticking in your brain. That is my prediction. Okay, so what else do you guys have? Other questions? Or I can just work something I think will be relevant. Do you guys have one for me, or do you just want me to work one that I find good? That I think. Let's see, what's a good one? I'm looking through your exam right now. And to be honest, the exam seems pretty straightforward, all things considered.
Do you know how many application type problems there are?
Well, I just looked through the whole one, and I think I only saw one.
One. Very good.
One that was just straight up applications. And it was, in my opinion, pretty straightforward. Not quite as bad as that piecewise one we did earlier. I think what would help as I look through everything. Let's talk about what it means to be a function. This was all the way back at the very beginning of chapter 2, so this is kind of the most distant stuff we've dealt with. Anywho, what it means to be a function. In words, what this means is that no x value should map to multiple y values. Let's look on a graph what that means exactly. So let's say you have a graph, and let's say that, and I'm going to have to draw a freehand. Let's say you had a sideways parabola. Now, we haven't talked about them, and we won't talk about them in detail. This is just to create a picture. Let's say you tried to graph this. Now, this is perfectly valid. This is fine. But let's say you have an x value of 2 here. because it's 2 on the x-axis. Well, this is going to map in 2 different places. This right here and this right here. So when you plug in an x value of 2, it's trying to spit out both whatever this y value is. Let's say this y value is 5. And it's also trying to spit out whatever this y value is. Let's say that this y value was -4. What this means is that 2, 2 comma 5 and 2 comma -4 are both points on this graph. They are. 2 comma 5 is right here, 2 comma -4. But notice the x value of 2 is mapping to, or it's pointing to, more than one single y value. That's going to be a problem. Because that happens, this is not a function. Technically, it's not a function of y in x, we would say, but well, that's great. But if you're looking at the graph, another way you can do this, you can use something much simpler called the vertical line test. And what you do is you just take a vertical line and you run it across the function. And if at any moment, you stop the vertical line and the vertical line touches the graph at more than one place, this is going to fail to be a function. So if you look here, if you run this vertical line across at every single point along the way, it's going to hit the function the graph multiple times. And so this thing fails the vertical line test immediately, even if it looked something like this. Let's give myself more. Yada, yada, yada. No. Even if it looked something like this. I'm gonna have to get creative here. Where it does something wild, I don't know. Looks like a wave at a beach or something. You run the vertical line across, it's actually fine, it's okay, no problems. It's only touching the graph exactly once. Let's make that a bit more vertical. It's only ever touching the graph at one point. Uh-oh, now it's touching the graph multiple times, but then it's back to being okay here. That's still going to fail the vertical line test. The vertical line test says you can run the vertical line across it, and nowhere is it allowed to touch the graph more than once. If it does it just a single time or in a very small space, that automatically still fails to be a function. So keep that kind of business in mind. What this means is, remember, there's another way that you can write functions or relations, we called them. You can also just use a set of points. This is what we would call a relation. All it is it tells you, all right, there's 4 different x values, 1, -3, +3, and 14. And the relation tells you what y values each of those x values points to or is related to. So this is the most general way. A graph is nothing more than a picture or a visual representation of a relation that looks like this, except you need a heck of a lot more points. You need many, many, many points, an infinite number of points, really. But this is still could be graphed if we wanted. We would just graph these 4 points, and that would be our relation. And so now this is the more general form of what it means to be a function. No single x value should map to multiple y values. So it's kind of like, this is kind of a weird analogy, but it's kind of like monogamy. Every x value has to go with just single y value. You can't, you kind of think of the guy who's dating multiple girls at the same time. You kind of think of him maybe as a sleazebag, especially if none of them would be cool with that, and he's just lying to them and saying they're the only one. That's sleazy. I guess if everyone's cool with it, that's their business, and I'm a libertarian. Not really, but I'm just kidding. But anyways, not to get off traffic here, but this single x value here of 1 only maps to a single y value. It's monogamous with it. Frankly, you don't see 1 appear again as an x value. So this 1 maps to 4, but we got to check all of them. This -3 only maps to 6. This +3 only maps to 6. This 14 only maps to 0. So this is actually still a function. This is a function. This is a function because every x value maps to only one y value. And now I know exactly what you're saying. But Josh, the y value of 6 shows up multiple times. That's going to be okay. Now, this is like the girl having multiple boyfriends or something, but in that analogy, but we're going to say that that's okay in this particular case here, because each x value was just partnered up with a single y value. Didn't, like -3 didn't try to also go to +5 or -72 or something like that. But this is not the case. So if you have multiple, or if you have the same y value mapping backwards to different x values, it's still a function, but what we say is that this is not going to be what we call 1-to-1, but we don't go into that detail. What's that?
So I was talking to them about review time.
Gotcha.
Sorry, they're paying attention. I just want to be.
Gotcha. Here's another example. And now we see this one will fail to be a function because the 2 here is trying to map to multiple y values, and that's just a problem. That's just an issue. So this one is not a function. This one down here is not a function because of that. I guess the only other note I could say is, what if we did this and we repeated this 0.25 and then we repeated it again? This is kind of really splitting hairs over semantics, but basically a repeated point is redundant. So 2 is still only mapping to 5. It's doing it again here, but it's still just 2 mapping to 5. In reality, in set theory and math, you don't need repeated points in a set. They're ignored. So this was actually what that set would become here. And then this would just be gone, baby, gone. So then this would be a function here. Let's see. Someone sent me a message in the Zoom. Is there a way you can record the Zoom meeting today and post it on Canvas? I'll do you one better. I'll post it on the YouTube channel. Remember, the link to the YouTube channel can be found in Canvas. So because obviously what we're doing right here is automatically going to be posted to the YouTube channel. And then I'll also post today's review session that we're going to do from 3 to 5. I will post that onto the YouTube channel. Does that help out, Gracie?
Yeah, I'm.
They're all on mute.
So yeah, if you go to the Canvas, if you go to the modules, you'll see the YouTube channel link. And you just open that bad boy up. And you'll see my channel, and you'll see I've put up every single time we've met. I have put the recording of it. Yeah, the one I'm doing tonight. So I'll also put that one on YouTube, and I'll put a special label on it saying it's the exam 2 review or something like that. So we maybe don't have enough time to do a whole other one. So I can field some kind of general questions if you guys would like. I can do general questions. Or I don't have any jokes because I've told you many times that I'm not actually funny. I just think I am. Earlier, what I said about being a libertarian, that was just a joke. So that was a joke. I actually pride myself on never revealing or tipping my hand about what my religious or political beliefs are, because A, I don't think it's my position as your math instructor to even go into those domains. So I just don't. I don't ever go into that. And B, well, that's really the only things. I've had students who've asked me what my beliefs are, and I won't reveal that. And then I'll say maybe at the very end of the semester, maybe I'll, but I usually won't go out of my way to do it. And sometimes I still won't. And I'll have students just guess what I am. And I've had students literally guess everything, things that I couldn't possibly be all of them. I've been called a Democrat and a Republican. I've been called everything. And I kind of pride myself on that because I don't want you guys to know what I am. Because I like to have the air of mystery around me because I think I'm really cool, when in reality I'm probably just deluding myself. But anyways, so you cannot guess what I am is my guess, is my hope, and I probably will never reveal it, and you probably don't care, but that's just me kind of prefacing or saying that, yeah, I don't reveal anything about myself. I do have a dog. I can reveal that to you. I have a dog. He's a bloodhound. He's a full
I'll try to come here today.
And if not, 106, anybody doesn't know what time you can do every.
All right. Y'all have a good day.